Hi, welcome everyone after the mid-morning break. I hope you have waken up a little bit, grabbed some food, some drinks, and are ready for another exciting session. I am thrilled to be here. This is my first Kubernetes Community Days kind of event. And gosh, it's been so long since I was in London for the last time. So this talk is going to be about Falco plugins and streamline detection. So this is not a talk about creating Falco rules. You have a whole workshop about that tomorrow. And this talk is more about all the capabilities that open up in the detection space. So a little bit about me. My name is Alba Ferri. I work as a senior product marketing manager at Sysdig with a focus on cloud security and CSPM. I joined the company 2 years ago, and I did it because I am a very curious person. And even though I come from the monitoring field, where I could see potential performance outages, I wanted to expand my knowledge about what else you can detect when you sneak deeper into the systems. And for that, Sysdig has a ton of expertise. Before that, I worked as a product manager and sales engineer for network monitoring tool that was based in open source projects. And before that, I was the sysadmin of the monitoring platform at Vodafone Spain that also happened to work with open source tools. When I landed in the security landscape, as I wanted to learn more, I thought that it could be a good idea to join the CNCF. So I joined the Spanish translator group, and one of our main tasks is to translate the cloud native security white paper that the SIG security group writes, and it helps educate users on how to create more secure cloud native applications. If you want to know what I'm up to, you can follow me on Twitter under Bramban2K. Okay, now that you know a little bit about me, I would like to know something about you. And let me ask you, how many of you have heard about Falco? Okay, and how many of you are currently using Falco? Not that many, okay. Well, for those of you who do not know Falco, Falco is an incubation level project within the CNCF. Even though we just applied for graduation. Falco was originally created by Sysdig. I think the first commit it was in January 2016, and later on it was donated to the CNCF. Since 2017, it has been a completely independent open source project. Falco joined the CNCF as a sandbox project in the fall of 2018, and 2 years later, it moved to incubation level. It is a container security tool that taps into the Linux kernel system calls and Kubernetes audit logs to create an event stream of all the activity. It is seen as the Kubernetes threat detection engine. So Falco can help you answer questions like, has my PostgreSQL instance spawned a suspicious process? Has anyone installed new packages or modified the configuration in my running container? Has my Nginx instance opened up a new listening port or outgoing connection? Or in the Kubernetes part, has a Kubernetes user spawned a shell in a privileged container? So things like that. But we think that with the additional capabilities that the plugins bring, it can move to more global threat detection engine. Some stats about the project. Well, we hit more than 5K stars score in GitHub, and we have more than 50 million downloads in Docker Hub. So thank you, anyone who has downloaded a container image. Okay, so I would like to give everybody an overview of the Falco architecture. At the lowest level, we have the drivers that work at the kernel space. The drivers can be either a kernel module or an eBPF probe. I will not extend myself on describing them, just to say that they are responsible to collect the system calls at the kernel level, and this is our source of truth, right, for our purposes. The event collection then uses the buffer ring to push uninfoliated events to the user space. Above that, we have the libraries. The first one is the libscap library that manages the collection of the events from the drivers. Okay, and then we have libinsp library that does the filtering, and it's able to send the information to other programs like stdout, syslog, http, etc. Something else that the libinsp library does is to create a state of the system, which is like a registry of every single process that is being executed. And then what we do with this state is making it accessible by rules and conditions. So if anything happens, changes, we can spot that thread or that abnormal behavior. Okay, so just to recap about the libraries, first we have the libscap library. It's the library for system capture. It's a user space library, so the drivers are in the kernel space, but this one is in the user space. It communicates with the drivers, and it collects the syscall events from the ring buffer. That's where the drivers place them, and then it forwards the events to the upper library, which is the libinsp library. And then we have the libinsp library, which is the library for system inspection. Again, is another user space library. It receives the event from libscap, and then it enriches this data with information like from the Docker daemon, the state, etc., and it performs also some filtering. Okay, so let me walk you through the evolution of Falco so you can see why we end up doing the plugins framework. So in the beginning, we were only able to monitor system calls. Okay, and that was already pretty neat because we could see all the information, all the activity happen in the containers, but we lack the context of those containers when they run using an orchestrator platform like Kubernetes. Sometime later, we were able to receive the Kubernetes audit logs. The implementation that we took, it was using a web server, exposing a web server inside Falco. So that was seen as an endpoint for the control plane, and we were receiving the audit logs. At this moment, we had 2 event sources, and we were able to enrich the information with data about, the pods, namespaces, etc. But this implementation also had its caveats. The API boundaries were not very clear. It was hard to instance. If you had a Falco instance collecting system calls, you could not use it to receive Kubernetes audit logs, and vice versa. Managing the TLS certificates between the control plane and Falco was complicated, to say the least. And something that was the big issue, or the biggest issue, was that it could not work with managed Kubernetes. Why is that? Because those Kubernetes logs are gathered and stored by the cloud provider. So we didn't have a method to, retrieve those logs. We needed to find a way to send them back to Falco. And now that problem has been solved with the plugins framework. Okay, so we have been able, using this plugins approach, to insert, to send those Kubernetes audit logs from EKS clusters. How does it work? Well, AWS stores or gets the audit logs, but then it also exposes them using the CloudWatch log service. So we've developed some libs that can create a clean session within the AWS API. So we can later pull the corresponding cloud log events, right? What else? Okay, a couple of things about this. First, we hope that having created this first managed plugin for Kubernetes audit logs, we open the door for other contributors to create a similar plugin for other managed clusters like EKS, GKE, for instance. And second, if you're willing to write a plugin for any other Amazon service, you can reuse those libs that we created to do that clean session with AWS API and retrieve the relevant logs from the CloudWatch log stream. Okay, so I've already started talking about the plugins, but I haven't formally presented them, right? What's the magic about those plugins? How do they work? Well, an easy definition of the plugins would be that they are dynamic share libraries that allow Falco to collect and extract fields from stream events. So we can have events from AWS CloudTrail, from CloudWatch, as I was saying, Azure Log Analytics, GCP login, but also things like the container daemon, kernel-D, or things that are not so much related with cloud infrastructure. And there is an example with Twitter, for instance. Okay, so we have two flavors in the plugins, and the first ones are the source plugins. They work with the libscap library, and they are responsible to open and close the connection to the event sources. It creates a batch of events that then are sent to the plugin by iteration. Okay, something you must know is that the source plugins must have a unique ID. Okay, and then the source plugin can also act as an extractor plugin, so it can retrieve a set of available fields and then extract that information. The other type of plugins that we have are the extractor plugins. They work with the sinsp library, and they are responsible just to extract the fields from source plugins or the core libraries. So they do not add any other new data source or stream event, just extract the data. And we have, for example, a JSON extractor plugin that you can use with whatever plugin, source plugin that collects information and in a JSON format, right? It works out of the box. Okay. A plugin can be written in any language. We have plugins written in C, C++, and Go, as long as that language support exposing C function interfaces that can be called from a C, C++ program like Falco. And we have already a module for Go for translating the C pseudotypes into C types, and also some methods that make it easier to write plugins in Go. Okay. And okay, the plugins work like the libscap library, the sequence would be like the libscap library calls the source plugin, that it opens the event store, starts collecting batches of events in iteration, and then it tells it to close. And then the structure plugin would work very similar, but instead of the libscap library, it uses the libins library and calls the plugin, gets the list of available fields, and then it structures them. Okay. So we are very excited about all the extensions that can be possible by using the plugins. With the introduction of plugins, there's potential for many new kinds of event stores and many new fields that can extract information from events. The plugin framework follows Falco's runtime security philosophy that is based on 3 key concepts. First, to parse data in a streaming fashion way that can detect threats in real time. Then implement detection on top of an engine that is lightweight to run and easy to use. And the third, offer a compact rules language that is quick to learn, but flexible and extensible. So this philosophy has already been proved to be very effective with syscalls, and now the plugins extend the applicability of this philosophy to an endless number of new domains. So we can apply it for CSPM, for IAM security, or source control versioning. And here I bring you some examples of the plugins that have been developed. The first one is the Okta plugin. So we're extending Falco to identity management type of services. I don't know if you're familiar with Okta. Okta is an identity service provider, is the one responsible or that help us not to need to put our credentials every time we change an application that is managed by our company. Well, early this year, Okta had a breach. The cyber security group called Lapsus claimed that they had breached the Okta platform, and they show some screenshots in their Telegram channel that they had like super user, admin, etc. So being aware of the plugin framework, the community developed a plugin that could detect things like a new user added to a Okta group, or a user logging from a suspicious country where you may not have an office, right? This plugin also brings new fields like the application that you're trying to access, from which IP address and the session ID, etc. So here we are using this source plugin to add a new event store like Okta. What happened is that in September, Uber claimed that, or said that they were one of the companies breached by the Okta breach. And they explain that the method the Lapsus group was using was the multi-factor authentication request generation, right? So that can be done using 2 type of events inside the Okta logs, which are MFA request and MFA denies. What happens with this is that the attacker logins repeatedly in the victim's account, and so it generates a lot of text push notifications, hoping that they get fed of it and they will accept one of those. So we came back and rewrite some parts of the plugin so we could catch those particular events, and that could be, or that's an example of a possible rule that you could use to detect such things. Here we're using in the condition the field octa MFA deny count last 100. That is the number of times that you say no in the last 5 minutes, and we've put a trigger that if that number is greater or equal to 3, then it will raise an alert saying that a user has denied too many times, MFA, etc., with the information that we're also getting from that source plugin. Okay. Okay, and then I bring you another example, the AWS CloudTrail plugin. With this plugin, we are extending Falco to cloud infrastructure. Because this plugin is collecting events from AWS CloudTrail, and you can do so by using 3 different type of sources, an S3 bucket, an SQSQ, or a local file system. Again, this is an extractor plugin, or it has extractor possibilities, and it brings new fields like name, user, info, etc. And we have another event store, another source to create our rules. So an example of rule that you can create using CloudTrail as the event source would be like detecting when someone updates a Lambda function configuration, right? So again, you have the field, and we use a condition in particular, and when that happens, you raise an alert from Falco that tells you all that information. The configuration of a Lambda function has been updated, and who has done it, the IP of that person, which region, and the name of the function. Another possible rule that you can create, like deleting bucket encryptions, for instance. Again, you're using the ct.name field and adding a condition, and if that happens, you've got an alert with that information. As I said before, more on how to create rules tomorrow in our workshop. Okay, and here is an example of an extractor plugin, okay? This plugin it works out of the box. You can use it, as I said, with any source plugin that is collecting information events in a JSON way, and it can also be used together with other extractor plugins or source plugins. Okay, so I think I'm heading to the end of the talk, and I would like to give you some useful links here to the project. So you have the documentation, also the registry of the plugins. That's very handful. If you are thinking about creating a plugin, you need to pick a source ID plugin that is not taken, okay? And the developer guide. We also have a great blog at falco.org, and where we explain deeper how to, create plugins, etc. And the last word about Falco, come visit us in the website, check out the project in GitHub, and we have a weekly meeting every Wednesday at 4 p.m. UTC that everyone is welcome to come. If you have questions about the plugins or the detection, etc., that's the place where you can come and chat with us. We also have a Falco Slack channel, Falco Kubernetes or something. And of course, you can follow us on Twitter under Falco _org. Okay, thank you very much. I don't know if there are any questions, or if we have time for questions.
You have time for a few questions. Yeah.
Okay, I don't know if anyone has a question. If a question pops up in your mind in a different moment, you can always come to our booth, at the SysDig booth, and ask us any doubt that you may have. Thank you very much.